name is Megan Durell, and my presentation is about the importance of lactate in the training of endurance horses. The article that I chose as a reference was published in 2010 in the Journal of Animal Science and is called the Maximal Lactate Steady State During Exercise in Blood of Horses. Many trainers who train horses for competitive events are constantly looking for ways to maximize the performance of the animal. Blood lactate levels can be assessed to achieve this goal. In humans, blood lactate levels are already used to evaluate and predict training intensities that will most likely increase the performance of the athlete. Blood lactate levels are also used in horses to evaluate performance, but they are not studied as extensively as they are in humans. The maximal lactate steady state is important because it is thought to be the ideal training speed. So what is this maximal lactate steady state, or max LASS? The maximal lactate steady state refers to the maximal intensity of exercise that produces a balance between the formation and removal of blood lactate. Now, as we all know, lactate production comes from anaerobic metabolism within the muscle, and the removal of blood lactate is stimulated through aerobic metabolism. Therefore, maximal lactate steady state is also known as the aerobic anaerobic threshold. Max LASS is achieved when the lactate concentrations do not fluctuate more than 1 millimole per liter of blood for 20 minutes of continuous exercise. Previous research that has been conducted in humans has shown that the maximal lactate steady state is reached at V sub 4. V sub 4 is the speed at which blood lactate concentration reaches 4 millimoles per liter of blood. Although the maximal lactate steady state has not been studied as extensively in horses as in humans, V sub 4 is also accepted as the velocity at which the maximal lactate steady state is achieved in horses. Therefore, the purpose of the article was to validate the previous research and to determine the maximal lactate steady state in horses. In order to confirm and define the maximal lactate steady state in horses, the researchers designed an experiment similar to that of the researchers who determined the maximal lactate steady state in humans. For their studies completed in the lab, they used 4 thoroughbred horses that were 3 and 4 years of age. They were housed in identical stalls and fed equal rations. The horses had been used in previous studies, so they were well habituated to their surroundings and the tools that were used for the research. The researchers also combined the data they collected in the lab with the data of 14 different performance horses studied in the field. In order to validate the maximal lactate steady state in horses, the researchers first determined the speed for each horse that produced a lactate concentration of 1, 1.5, 2, 2.5, and 3 millimoles per liter. These speeds can also be denoted as V sub 1, V sub 1.5, V sub 2, V sub 2.5, and V sub 3. These speeds must be determined for each horse individually. In the standard exercise test, the horses are exercised for a set amount of time or a set distance, and this is dependent on whether the horse was used in the lab or in the field. The blood was then drawn from the horses and was analyzed to determine the blood lactate concentration. The speeds that produced the desired levels of lactate were calculated using a mathematical equation. After the standard exercise test, the horses used for maximal lactate steady state validation in the lab were exercised at their individual V sub 2.5 and at their V sub 1.5 for over 40 minutes. Horses that were in the field were run for 15 to 20 minutes at their V sub 2. Blood was drawn from all of the horses during each exercise session at predetermined intervals. The blood was then analyzed for lactate concentration using 2 different methods of analysis. The maximal lactate steady state is reached when the blood lactate concentrations are maintained within 1 millimole per liter of blood for 20 minutes of continuous exercise. So what did the researchers find? Well, from their study, they discovered that the use of V sub 4 as the max LASS does not hold true for horses. Conversely, they discovered that V sub 1.5 was the intensity that most closely matched the description of the maximal lactate steady state that had previously been defined. However, the authors did suggest that horses exercise outside of the lab at their individual V sub 2 are likely able to sustain blood lactate concentrations for 20 minutes of exercise. This graph was used in the conclusion by the authors, and it depicts how blood lactate concentrations change with continuous exercise. The graph also shows how the blood lactate concentrations are altered by the different speeds that were determined in the standard exercise test at the start of the study. This graph was useful in showing how the blood lactate concentration changed at different speeds and how the concentration changed during 26 minutes of exercise. Well, that concludes my presentation. Thank you for listening.